So continuations of the Newton's law, we are dealing with strings and pulleys. These are mainly talking about the third law. Okay, the rule is basically saying that we assume all the string and ropes doesn't have mass, and we think that the force from one end, it's all gonna be transmitted to the other piece of cord, and they can only be pulled. It will not be pushed, and it does not stretch. Pulleys are all frictionless and massless. And with any type of question, string and pulleys questions are very much relating to the third law. If I have an object that is connecting to another object, the first thing you need to realize is that this is a singular rope, and they're saying that the pulleys, it's gonna experience a force of tension being pulled forward if I call this mass 1 and if I call this mass 2. Mass 1 is going to be dragging mass 2 towards the forward direction, but at the same time, the mass 2 is going to be dragging the mass 1 backwards. And there is an assumption that because this is the same rope and this is the action-reaction force pair, those two are assuming to be the same. So I believe we've already mentioned it. As long as it's the same rope, the force of tension is the same. That's the assumption. Okay, so example number 1. A 2 kilogram is placed on a smooth, level table and is attached by a light string passing over a frictionless pulley to a 5 kilogram mass that is hanging freely on the edge of the table. Calculate the acceleration of the 2 kilogram mass. So I want to find the acceleration and the force of tension that's on the string. Okay, so things to consider whenever we're doing pulley question. There are assumptions that the system moved together, so we can assume that the accelerations are going to be the same. We're assuming that they're tied together, and if one system starts to accelerate, the other will move with it. And we already talked about the other thing is because of the same string, force of tensions are also the same for the same string. With these types of questions, it's always good to kind of break the question into 2 sets and draw the free body diagram for each and analyze the forces for each. So I'm going to call this block 1 and I'm going to call this block 2. I'm actually going to color coordinate it, so I'm going to use 2 different colors. So I'm going to use blue for 2. So I'm labeling them. Okay, so for block 1. Block 1 have a mass of 5 kilograms. And I will always draw the free body diagram first. So kind of step is you would always draw the free body diagram and include all the forces with it. So this is a block that is hanging there, and the block is going to experience a force of gravity that's going down, and because it's hanging there with a rope, I can also know that there is a force of tension that is there. Okay, number 2, after you've done that, you have to assume where it's going to be going. Okay, you're going to assume the direction of the acceleration. Okay, this I'm going to ask you to refer to your common sense. Okay, which way do you think the block will be moving? Is it going to be going to the right and down or left and up? I think the only sensible is that it can only be traveling downwards for this block because it's being hanging there on a pulleys. The most it can do is that it's not going to move, but it would never go the other way. It would never start traveling upwards. It just won't happen because of force of gravity, the nature of force of gravity. So step 2 is you assume the direction of acceleration, and then having common sense, I'm going to skip ahead to the second block. If I know that this guy is going downwards for block 1, then block 2 is going to have to be traveling to the right. Okay, so hopefully that's the common sense that we're going to be able to establish. Okay, step number 3 is you're going to write your F net equals to whatever minus whatever equals MA. Okay, you're going to do your net force equation for the block that you have. Okay, and this block is traveling downwards. So the net force along y in this case is going to be down, which is Fg, minus up, which is Ft, equals to ma. So this is your net force. Just want to review doing net force. I know that I talked about it before. I just wanted to make sure. If I say calculate the net force for 2 Newton and 1 Newton, the first question I asked you, which way is the acceleration? Okay, without even doing the math, is it fair if I say the acceleration is going down? The second thing that I'm going to ask you is, how do you calculate the net force? I think most of you are going to be able to tell me it's 2 minus 1. The reason why you would put 2 is because 2 is the bigger number. So the bigger value means that the direction of the acceleration. So that means from now on, even if they don't give you the direction, if I call this F1 and F2, but if I tell you that if the acceleration is downwards, then my net force is F2 minus F1. Is my net force equals to ma. If I vice versa and change that around and say, hey, how about if I have a block that is going, I don't know what the value is, but I'm going to make up F1 and F2, and I tell you that the object is accelerating to the left, then your net force is going to be the left minus the right. Like, you always take the direction of the acceleration as being positive, and that's your F net equals to ma. Okay, so hopefully that clarifies for you, and that's why in here, because I'm going downward, that's why I'm saying it down minus up equals to ma. Some things that I know mass is 5 kilogram, and I know Fg. I know that there's another equation for Fg. I can plug it in as mg minus Ft equals to ma. I'm going to plug in my value as 5, because that's my mass, times 9.8 minus ff equals to 5 times a. I don't know what a is. Okay, but this is what I know, so I'm just going to multiply it out. 5 times 9.8 is 49. 49 minus ft equals 5a. This is all that I can do. I'm going to stop here. I have 2 equations, but don't forget, because I know that ft and a are the same, from the blue color, block number 2, I can now calculate what is the a and what's the t. I have 2 equations with 2 unknown, and I'm going to put them together. Okay, so I'm going to repeat everything for the blue now. I'm going to first of all say this is block 2. The mass for block 2 is 2 kilogram. I'm going to draw my free body diagram. Okay, I forgot to mention that when they say a smooth level table, they're asking you to assume that there is no friction. So that means I have a rope that is pulling forward, which is Ft. It is sitting on a counter or whatever the table is. I do have an upward Fn, and I have a downward Fg. Direction of acceleration, we already talked about it. If the 5 kilogram have to be going down and it's being hooked by a string, then your 2 kilogram is going to also have to go towards the left. I'm doing fancy pencil here. So I'm going to have to say that the acceleration is to the right. So when I write the net force, your net force is going to be forward minus backwards. My forward force would be Ft. I do not have any force that are going backward. No backward force, so I just have Ft equals to ma. And Ft I don't know, but m is 2, and a I don't know. So Ft equals 2a. So I got this equation, and I got this equation. So 2 equations with 2 unknown. That means I can use substitutions, right? So I can put my Ft into that. Okay, so 49 minus Ft. If I sub in Ft, it means I'm going to put the 2a into it, equals to 5a. So all I've done is I have entered, doing substitutions, replace the Ft by the 2a. Now I've eliminated all the variable for Ft. I now am going to collect like terms and then divide. So I now have 49 equals 5a adding 2a. So solving for that, a worked out to be, so 49 divided by 7. So 7 meters per second. and I'm going to put in my sigdigs. There are two significant digits in this case. So acceleration is 7 meters per second, and it is asking me what is the acceleration of the 2 kilogram block. So I do have to worry about the direction. It is going towards the right. You can say forward because the question didn't specify. Okay, part B asks you to calculate force of tangent, but it didn't say which block, because force of tangent could be going to the right or could be going upwards, right? Because it didn't say the direction, like didn't say which block we're talking about, and there could be forces in different direction. You don't have to put the unit down. Okay, so you can pick between the two equations that you originally written out. So you could either pick ft equals to 2a or 49 minus ft equals to 5a, and then do your substitution of a back into the original equation and solve for ft. So I'm going to pick the easier one. I'm going to pick the ft equals to 2a, and a is 7. So I got ft to be Newton, and as I said, it could be to the right or it could be up, so we don't have to write the directions. Okay, question 2. Consider a real-life application of elevator 1, M1, and the counterweight M2 to minimize work done by the motor to raise and lower the elevator safely. M1 and M2 are similar in mass. The mass for the counterweight M2 is 1000. Assume the mass of the empty elevator is 850, and the mass when it's carrying 4 passengers is M1 equals 1150 kilogram. Calculate the acceleration of the elevator and the tension on the cable. So you got 2 blocks, and they are done by a motor. So you got block that looks like that, and then it's gonna hang on to a pulley, and they tell you M1 and M2. Okay, this is a pulley, and they're frictionless. First of all, sigdigs, I am so sorry. Can you please change this question to 1.0 times 10 to the 3 kilogram? So I do want it to be 2 sigdigs. Okay, it's carrying 4 passengers. And then the mass of the empty elevator we're going to use this as the M1. I know, don't you hate it when the question is not really clear on what they want you to do? So they do want you to use M1 to be 1150. Okay, the rule stays the same as the one that I was giving you. Like just now, I'm going to review this block right here, where it says the 3 steps. We're going to follow the exact same steps. Okay, draw the free body diagram for each of the block. Assume the directions, which way should they go, and write F net equals to MA, write out the net force for each of them. Okay, so first one, M1, the mass for M1 is 1150 kilogram. Okay, the free body diagram for M1, there is a force of gravity pulling it downwards, and there is a force of tension that's pulling it upwards. Direction of acceleration, okay, M1 is heavier than M2, so we can assume that the M1 is going downwards and the M2 is going to be going upward. Remember, the two things are tied together. If one goes down, the other has to go up. Okay, and it does make sense to make the heavier one to be going down first, right? So that's my M1. I'm going to write my F net. Because this is going down, F net is going to be down minus up. So my F net is going to be FG minus ft equals to ma. Whenever I see the equation fg, I right away convert it and put in the mg equals ft times ma. So I know m, this is m1. That's why it's important for you to write the proper mass. You know, like you're dealing with this mass. This is the mass that I'm using. I'm talking about this one block. So this is 1150 times 9.8 minus ft equals 1150 times a. Multiply out the force of gravity, so 1150 times 9.8, 11270 minus ft equals to 1150a. That looks like that's all I can do. This is my first equation, and I'm going to move on to the second one. I don't have ft, I don't have a, I can't move on anymore. So let's do block 2. So block 2, I'm going to do the same thing. First of all, write out the mass above. Okay, and I'm going to draw a free body diagram. So for block 2 still have force of gravity acting on it and still have force of tension going on it. So they look exactly the same. The only thing is now the step 2, direction of acceleration is going upwards. And so I would not write the same equation as I did for block 1. You have to be careful. When the net force is going up, it's up minus down. Okay, if you need me to scribble again just to make sure. Okay, don't write this down, or you could. But if I say the acceleration is going up and I tell you that this is 5 newtons and 3 newton, would you say 3 minus 5? You will go up minus the down, right? Because the only way it can accelerate upward is because the upward has a bigger force, right? So you have to write the up minus the down. So going back to the equation. So for me to write this up, this is F net is going to be up minus down. So Ft is going upwards, Fg is going down, equals to Ma. So I'm still writing my second law first. The F net equals to Ma. So Ft I can't do anything about, so I don't have anything, but I know that I can solve for what is Fg, right? M times A. So Ft minus 1000 times 9.8 equals 1000 A. Very clearly, right? Like, it's nice to keep yourself organized. Keep it in a little column. All right, so multiply it out. So 1000 times 9.8. You should be able to do it in your head. So Ft minus 9800 equals to 1000 A. Okay, 2 equation with 2 unknown. You sub one into another. So it's up to you how you want to do it. So if you want to, I'm just going to rearrange this equation for Ft by bringing the 9800 over to the other side. And when I do that, it used to be minus, so I have to add it to the other side. So Ft is 1000A adding 9800. And I'm going to sub this equation into the other equation. So 11270 minus Ft, which is whatever this represents, right? So 1000A plus 9800. So I've subbed in my Ft equals to 1150A. So just doing substitutions. If there is a minus inside a bracket, don't forget you have to expand it out. So this becomes 11270 minus 1000A minus 9800. Be very careful with your sign. If you end up with an A equals to 9.8, you know you either flip your equation or you've messed up your plus minus in some way. Okay, find it. You will not. It shouldn't be 9.8, right? If you got 9.8, you screwed up your sign somewhere. Okay, so now collecting like terms, I'm gonna bring my 1000A right here to the other side by adding, and then I'm going to just sum up these two, right? So 11270 minus 9800. So I got 1470 is equal to, I'm going to take 1150A adding the 1000A and then divide it on the other side. So you should end up with A equals, I got 0.68. Is that really small? Okay, 2 sig digs. Let me just double check. I feel like I've done it wrong, but maybe it's okay. Okay, 1470 divided by 2150. So I got the acceleration to be 0.68. Is that what you got? Okay, good. Okay, and they did ask, what is the acceleration of the elevator? Elevator is M1, so the direction for the elevator is down. As I said, if they didn't specify the particular object they're talking about, you don't have to put the direction. So that's part A. Part B now asks you to find force of tension, so you can use any of the equation. So I'm just gonna go back because this is the blue one. This one is gonna be the easiest one to use because it's already isolated for Ft. So for part B, I'm just going to do it over here. I know that FT is 1000A adding 9800. So 1000 times 0.68. I already found it. So I'm just subbing it in to find the other one. So I got the force of tangent to be some humongous number, something like that. And we would like to express it with two significant digits. Okay, pause the video. How do you do this in two sig digs? You can't put 10,000. So I want to keep these two and round the rest. You can't round up the 4. You don't double round. Some people would round this up to a 5 and then round this up to a 1. You can't do that, okay? You always just look at whatever the digit behind the place where you want to round. So that means this particular question, the only way that you could express it with two sig dig is if you put it in, oh, our favorite thing, scientific notation. Ta-da! All right, so this is done. It didn't mention which one. It just says the cable, tangent in the cable. So no direction is needed for this one. Okay, question 3. You finding her car stuck in the mud. We actually have to try it. I was stuck in the snow one time and I actually have to try to get my car out of the ditch. And then I was like, okay, think of all the physics question we've done. How do I get it out? So ended up, I didn't quite use a rope and pull, but ended up we did use the natural frequency. I don't know if you learned it in grade 11. Everything has a natural frequency. So we actually rock the car and find a natural frequency, because if you're able to find a natural frequency, you can, with the very small forces, you are able to get a very big amplitude. And so we actually got our car out. It was so snowy that day. But anyway, okay, finding her car stuck in the mud. A bright graduate of a good physics course tied a strong rope to the back of the bumper of the car and to the other side of the tree. We did something very similar to this. I don't know if you remember, there was another example that looked so much alike and ended up whatever force you're able to apply. If you're able to get two ropes to gain the mechanical efficiency, you can actually get a good, get a much larger force. And that's all right. So they said estimate the force of the FA is 300, and FA is this guy. This is your FA. Okay, so you're the person is pulling right in the midpoint right here, and then it's starting to, the car just begin to bulge. This is something that we also need to talk about. When something just begins to bulge, you actually have an assumption that the acceleration is 0. Okay, whenever that they say something just started to move, okay, like it hasn't moved yet, but it's just starting. Okay, and they're telling you the rope at the angle, which she estimate to be 5 degrees. This is 5 degrees. Or this is 5 degrees. Okay, I'm going to draw the picture slightly bigger, because if you can recognize this is a first law question. It's in this lesson because it includes the rope. And when it's the same rope, what did we say? If it's the same rope, force of tangent are the same. So you're applying a couple of things. This is a first law question. Acceleration is 0. This is also a third law question because of the rope being the same. Okay, so let's just draw a picture bigger just so that we can split it up into the XY axis. So this is we consider this a two-dimensional question because it now involves the X and the Y axes. Okay, so I'm going to draw my FA, and I know that the FA is 300. And then I'm going to draw a force of tangent that's coming down this way. And then another force of tangent. They are the same rope, so they are the same. And they do have an angle of 5, okay? So what you're going to do is you're going to break it up into the XY component. Every time when you see forces on an angle, a lot of time, you're putting them into the component. So I'm going to now start splitting this. So I have something going east. Going to the right, and then something that's going downwards. I don't know if it's north, east, southwest. You're looking at it a bird eye view. Okay, this is 5 degrees. So this is opposite. So this side is opposite to the 5 degree. So this is FT sine of 5 degrees. And then the along X is the cosine, FT cosine of 5 degrees. And then on the other side, I have the same thing. Okay, it's going to the left and it's going down. And the angle is 5 degrees. So the y is ft sine 5 degrees. And then the x is ft cos 5 degrees. Okay, sum up the forces. Is it x, is it y? So let's deal with the y first. Okay, and I know I sound repetitive, but I just want to make sure you get that. When the acceleration is 0, it doesn't matter if you go up minus down or down minus up. Because when something, the acceleration is 0, the forces are balanced. Okay, so I'm just going to go up minus down. I'm going to call this up. So I got 3 forces in total, right? I got the upward force and then 2 downward forces. Okay, so up minus down. So I'm going to go up minus down. They're the same. So I'm going to skip ahead and say that this is 2ft sine of 5. It's equals to ma. F net equals ma. I always still start with that. But because a is 0, I can cancel that. So that means I actually can already solve for my ft. And that's what they wanted you to find. So fa is 300 minus 2ft sine of 5 equals 0. So move the negative to the other side and then divide both sides by the 2 sine of 5. So ft would work out to be 300 divided by 2 divided by sine of 5 degrees. So 1721. So I got something like this. Okay, round it to the proper sigdic, which I fail again. I put 300. Can you just assume 2 sigdics? It's my fault. Questions are not careful. Just assume 2 sigdics. So 1.7 times 10 to the 3. Or you can just say 1700, which is fine. There could be 2 possible directions. So I'm not going to write the direction. But I want you to look at the magnitude again. 1700 compared to the 300 that you started off with. You've totally gained mechanical advantages. Meaning by applying a small amount of forces, if you know how to tie your rope, you can get it to be a lot stronger. And that's like simple machine, right? Why do we invent a stairs instead of using ladder? All these are with smaller force, you can accomplish bigger things. Okay, last one. A muscle man, so like me, I'm super strong. I am trying to lift the piano slowly. Right? Don't you hate this word? Slowly also means acceleration equals to 0. Yep, assumption. Okay, and it is now using a rope. If the piano has 200 Newton weight, when they say 200 Newton weight, they're telling you that weight means Fg. They're telling you Fg is 200 Newton down. Okay, it's being pulled up by a rope, and the 2 ropes are both going upwards, and because they're the same rope, the 2 Ft are the same. So the free body diagram for this particular, like at the piano, I'm going to know that there is Fg that's going down. I actually have 2 Ft that are the same value that are going up. And there is an assumption that the acceleration is 0, is moving slowly. And wordings like that is indicating to you that they are moving at a constant velocity. So what is the F net? Okay, I'm going to go up minus down. This one doesn't matter again, right? Acceleration is 0. So I'm going to go up minus down. So up, I have 2 forces, minus down. You can say 2Ft equals to ma. Net force equals to ma. A is 0. So 2Ft is going to equals to m times g. Is it okay that I've totally skipped all these steps? Fg, I move it over, it becomes positive. And then m times g is the equation for Fg. So 2Ft is going to equals to the mass times 9.8. They already gave it to you, which is 2. Okay, I'm sorry. I didn't even need to do that because they already told you Fg is 200. So you really could have just left it at Ft. So I'm just going to erase this. My bad. I'm just going to say FG because they already gave it to you. FG is 200. So FT worked out to be 100 Newton and is going upwards. Both string are upwards, so I do write the direction because I know what it is. And if you look at the picture, this is to 100, but it's also the same force that this person is pulling. Meaning, if I put in the pulleys and I put two strings that are going upwards, this person can use half of the force and be able to lift up the piano. Okay, and that makes it super sweet. Okay, so hopefully by this class, you're good to know how to write F net equals to MA. And you also know that force of tensions are the same for any ropes that are continuous. Like if you have two ropes, you assume the force of tension to be the same. And then the third thing you should realize is that any of the blocks that